Hello everybody. In this video is presented the poster titled Effect of Hydrostatic Pressure on the Structural, Electronic and Mechanical Properties of Strontium Iodium Oxygen 3 Perovskite. The strontium iodium oxygen 3, hereinafter SNO compound, is a very interesting material due to its physical properties, unusually incompatible. It shows a metallic behavior and a photocatalytic response to an electromagnetic wave of 1.9 electron volt. Also, it preserves the conductor behavior and is transparent when it is a thin film. Therefore, it is a promising substitute for ethos substrate. In this work, the structural, electronic, and mechanical properties of the SNO compound were investigated under hydrostatic pressure ranging from 0 to 100 gigapascal by computational calculation in the density functional theory framework for the orthorhombic PNMA and cubic PM-3M bulk phases. Results and discussion. Enthalpy difference shows that at 0 gigapascal, the orthorhombic phase is the most stable by 0.29 electron volt per Fermi unit over the cubic phase. However, at 10.25 gigapascal, a phase transition is identified since orthorhombic and cubic are degenerated in energy, and for greater pressures, the most energetically stable is the cubic one. As pressure increases, lattice parameters decrease by the niobium oxygen and strontium oxygen bond lengths decreasing. Therefore, the octahedral distortion increases and tilting theta and phi angles increases from 0 to 10 gigapascals. Afterwards, bond length decreases. Electronic band structures and density of states are mainly made up by three sets of bands, B-1, conduction band, and B1. They are principally composed by oxygen P, niobium D, and strontium D states respectively. Electronic band structures show a direct interband transition from 0 to 10 gigapascals for the orthorhombic structure at gamma point, accompanied by an increase and as consequence of the structural distortion increase, which causes a detrimental overlapping. For cubic phase at 10 gigapascal, the interband transition increases and changes to an indirect from air to gamma points, and then it returns to a direct one at gamma point for pressures greater than 30 gigapascal, while the interband transition continues decreasing. These three bands are widened in energy, then the interband transition decreases from 2.0 until 1.51 electron volt at 0 and 10 gigapascal respectively. On the other hand, Hirschfeld analysis revealed a transferred charge from oxygen to strontium and niobium, denoting a metallic behavior increase because of the shortening strontium oxygen and niobium oxygen bond length. This is supported by the Puch criteria and Poisson ratio, which indicate a ductile and metallic increase in behavior respectively as the applied pressure increases. Mechanical moduli increase, while bigger hardness decreases as pressure increases. This supports the Poisson ratio and Puch criteria. Then the by temperature decreases. On the other hand, the anisotropy factor increases as the pressure increases, so an anisotropy increment is marked. In summary, this study shows a way to improve the electronic properties of SNO perovskite by applying pressure for practical photovoltaic applications like hydrogen generation and solar cell device. In addition, the mechanical moduli increase accompanied by the bigger hardness and the by temperature reduction indicate a more resistant and less hard compound, which could be an advantage for flexible photovoltaic device. Thank you for your time. You can find this poster in the poster session next Monday at the IMRC 2021.